Oxidation number is nothing but, you can say, the charge on the atom. Okay, charge on atom or compound. Okay, atom or compound. We will find now for elements only, because for compound we will go for complex compounds. When we'll go to complex chemistry, coordination chemistry, that time we will learn about the oxidation number of the compound. Now, oxidation number of an element. Okay, now if element is there, suppose an element is there in your elementary form. Okay, for example, your O2. Okay, and you can say nitrogen N2 or Cl2, all these things if you have, that time we will say this the oxidation number is 0. Okay, so because it is bonded, now I can say one property is that just see here, because oxygen and oxygen, okay, there is, you can say, there is total, we can say, double bond is there. Okay, so these are all, octet is fulfilled. So octet is fulfilled, there is no charge left. That means this oxygen is neither it will take or give electrons. So that's why you can say the charge on the atom is 0. So element in when it is in elemental state in this form, that time the charge is 0. Okay, so we can say whenever there is, you can say, loss of electron. Okay, so electron, that time what happens is that positive charge comes on when it's loss of electron, and when it is gain of electron, okay, so that time it is minus negative charge adds on the atom. And we also say this is called loss of electron, is also the process is called oxidation. Okay, and in this process this is called your reduction, the process. Okay, this is process, and the thing which is reduced is called the element, or the thing which is oxidized, that is the element. Now we will take the compound as HNO3. Okay, now if we say that find the charge of the nitrogen atom, how will you find? We know oxygen being an electronegative element, it tries to take up 2 electron, okay, to form octet, so it is always -2. And hydrogen, we know it always easily gives up electrons, so it becomes +1. Okay, so the other one which we can find is, like, see here, 2 to 3 are 6 here, so now we can say +1 plus x plus -2 into 3, which should be equal to 0. Okay, so this is your basic formula. So now what happens is that this is 1 plus x minus 6 is equal to 0. That means x minus 5 is equal to 0. So x is equal to 5. And what is this x? This is nothing but the charge on nitrogen. So we will say nitrogen here is how much? +5. So this way we find the oxidation number. Okay, now we can go for other elements. Now this is your one element. Now let me take the other element, that is your HNO2. Okay, now what happens is that in this case, see here, it is -2. -2. Okay, now this is -2, and now this is your +1. So here, see, 2 2s are 4. 2 2s are 4. 4 plus -4 plus 1, that is your +3. So your nitrogen should be +3 to make it balance. Okay, so your nitrogen is now +3. So nitrogen, charge of nitrogen here is +3. Now the other thing is, like, if you find CH2Cl2, okay, for this compound what we will do, CH2Cl2, now this is your -1. We know chlorine is an electronegative atom, so it will try to take up electrons. Okay, so it is -1. And now this one also we know it is hydrogen, is again +1. So here it is, now see here it is +2, and here it is -2. Okay, +2 -2. So here we can say the charge on the carbon is 0. See, it is 0. Why? Because see here, this is like x plus 1 into 2 plus -1 into 2, which is 0. So x plus 2 minus 2 is equal to 0, and x equal to 0. So the charge on carbon is 0. Number 4, if you take the fourth element, suppose if it is CCl4. Okay, now in this case what happens is CCl4, if it is -1, okay, so now this is 4 1s are 4, so it should be +4 to make it 0. Okay, so number 5 is CO2, if you say, so here again -2 2 2s are 4, so again it is +4. Okay, so this way you can find the oxidation number of anything. Number 6, if I take this one, H2N2O4. Now if you have to find the oxidation number of this one, how will you do this? This we will do like this. See, if it is H2 and N2 and O, 4 na. So minus 2 for oxygen, so 4 2s are 8, and we know plus 1, so 8 plus 2, that means it is plus 6, so it should be plus 6. But nitrogen, just because it is 2 molecule, hence it should be plus 3, so 3 2s are 6. Done. This way you will find the oxidation number. Number 7, let's see, again I will take Na2S4O6. okay, so this is a very big number. Now suppose again here we know it is minus 2 for oxygen, we know it is plus 1 for sodium, so it is 6 2s are 12, 6 2s are 2 into 1, plus you take X for sodium, okay, then plus you take this one, 6 into minus 2, which is equal to 0. Now it is your 2 plus X minus 6 2s are 12 is equal to 0. That means X minus 10 is equal to 0. So X is equal to 10. Now it should be plus 10. For S4, that means the sulfur, the charge on the sulfur should be divided by, should be 10. Total S4 should be 10. But what will be the, just for sulfur, what will be the charge on just sulfur? So what we will do out here is that if you check this, it is like your X4 na, so it is 4X is equal to 10. Now so it will be X, so it should be 4X, okay, 4X, 4 sulfur, no, so 4X, so X will be 10 by 4, which is, you can say, 2 2s are 4, 2 5s are 10, so the here charge is 5 by 2. So charge can be also, you can say, it is can be also fractions also. Oxidation number can be in fraction also. So this is all about oxidation number. I hope you understand, and if you don't understand, please pin me in the comment. I'll try to find more examples for you. Okay.